All right, guys, so in this video, we're going to go over the process for linear programming, okay? That's applying the systems of linear inequalities that we've been working on the last few days, okay? So there's quite a few steps I'm going to talk about here. I'm not going to read all of this to you, so at any time, if you need to, pause the video and kind of read through the steps. But these first three steps are really mental steps. They're thinking steps, okay? Understand the problem. Okay, what we're going to do here, linear programming, the goal of that is to maximize or minimize some quantity, okay? And we're going to have an objective function, okay, which we're going to talk about here in a little later. And we're going to have constraints, okay, limitations that are placed on us by the situation, okay? Again, 1, 2, and 3 are mental steps. Describe the objective, okay? You need to think, and usually it's going to be in the question. What exactly are we trying to maximize or minimize? Okay, what's going to happen with our constraints? It's going to allow us to maximize something like profits. What's going to happen with these limitations to help us or minimize costs? All right, then we want to describe the constraints. We're actually going to write inequalities. That's going to be one of the steps later on. But remember, we've been translating phrases into inequalities. You know, phrases like less than, using phrases like at most, phrases like at least, and so on, okay? As you're reading through the problem, you want to think about how you're going to form linear inequalities based on the constraints given in the question or in the problem, okay? Now, the rest of these steps are steps you're actually going to work out. You're going to write something out. There's going to be some work product that occurs in steps 4 through 8, okay? So step 4 is define the variables. Generally, the ones we're going to be working with in this class, we're just going to have x and y as our variables because we're going to be graphing these in the coordinate plane. But we want to spell out what they are just so we don't get lost, okay? I did use an example here. If you want to use other variables, like if we had candles and flower arrangements, I could use C for candles and F for flower arrangements. But one of the things we've talked about in class is kind of sticking with x and y. That way it, you know, gets rid of any confusion you might have when we start graphing, okay? The objective function, again, what are we trying to maximize? What are we trying to minimize? All right. This is just going to be an algebraic expression. All right. We're not going to write an equation. We're not going to write an inequality. We're just going to write an algebraic expression. All right. And we'll do a couple examples here to help you understand that. Write out the constraints. This is going to be our system of inequalities. Okay. System of linear inequalities. Based on the wording of the problem, we're going to write out 2, 3, 4 types of inequalities to help us determine, you know, the values we need to check in order to maximize or minimize, okay? We can add any non-negative constraints, all right? I'm not going to actually write those out as an inequality, but we will talk about those, all right? When we're producing something, when we're manufacturing something, when we're making something, you know, you can't make a negative number of pizzas. Okay, one of our examples includes pizzas. You can't have a negative number of large pizzas. So we want to think, even if we don't write these out physically, we want to think about non-negative constraints, which will put us totally in quadrant 1. Okay, last 2 steps. Once we've graphed, we're going to end up with some geometric shape. It's going to be, you know, a triangle. It's going to be some quadrilateral of some type. Depending on how many inequalities we had, our feasible region could change shape. All right. The ones that we're going to deal with in both the examples worked here will end up with a triangular feasible region. All right. Once we're done with that feasible region, once we find the shaded region that fits all the inequalities, we want to determine the coordinates of the vertices. Okay, it's going to be the vertices of the triangle in the examples I'm going to work below. Okay, these vertices, those coordinates, are going to be the values that we test in our objective function to tell us whether we found the maximum outcome or whether we've minimized cost or something like that. Okay, this is going to be the answer to the problem. Once I test those vertices and see which one gives me the greatest answer if I'm maximizing, or see which one gives me the smallest answer if I'm minimizing, will be the answer to our problem. Okay? All right. So again, if you need to, scroll back or rewind, read through those steps. Okay, but let's look at example 1 here. We've got Ariel, who makes greeting cards. All right. She receives $4 for each regular card and $6 for each custom card. Each week she can make at most 18 of the regular ones and 14 of the custom ones. And she also knows that she will make more than 20 cards each week. All right. Ariel wants to maximize her income, so that's what we're maximizing. So again, steps 1 to 3 are all mental steps. Think about the problem, and we'll discuss some of these as we go through the last few steps. Step 4, let's define the variables. So I'm going to use X as the regular cards, and I'm going to use Y as the custom cards. It's important to spell that out. Okay. Step 5, write the objective function. All right, we're trying to maximize income. So this is where we're going to use these dollar amounts. This is the income she receives for each card, okay? So she receives $4 for each regular card, so 4X. She receives $6 for each custom card, 6Y. So we want to add 4X and 6Y together. That's our objective function. Again, notice this is not an equation, this is not an inequality, it's just an algebraic expression. Okay. Step 6, let's write out our constraints, and we're going to graph those, okay? So in reading, one of the things we see here, she can make at most 18 regular cards. Okay, so that inequality would be X is less than or equal to 18. She makes at most 14 custom cards. So Y is less than or equal to 14. And then we know she's going to make more than 20 cards each week. Okay? So X plus Y is greater than 20. Make sure you understand there's no equal to there. More than 20 means 21 or more. Okay? All right. So let's graph these constraints. First, I'm going to graph this X is less than or equal to 18. Okay? I would shade, I'm not going to shade yet, but this is the vertical line, and we would shade to the left of this. Okay? Y is less than or equal to 14 is going to be this horizontal line here. Okay? So if I'm shading left of the vertical line and below the horizontal line, then I'm looking at this region for now. And then finally, X plus Y is greater than 20. Okay, we can graph that using intercepts. The X-intercept and the Y-intercept would both be 20. Okay, but I'm going to shade above that line. Okay, so this is the triangular region that would be my feasible region. Okay, so I'm going to shade that in. That's the area I want to look at. Okay. Step 7, determine the vertices. So my vertices here are 6, 14, okay, 18, 14, and 18, 2, okay? So you want to make sure your graphs are exact, or you're using some graphing technology, whether it's a graphing calculator in your hand or online, okay? So these are what I want to plug into my objective function, okay? I'm going to plug each coordinate pair into my objective function. I'm maximizing income, so I want to see which one has the greatest value. Okay, so step 8, test the vertices. Okay, so we're going to plug in 614 first. That gives me $108 total. 24 plus 84 is 108. Okay, now let's test 18 and 14. Okay, which gives us 72 plus 84, which is $156. And now let's test 18 and 2, okay, which gives us only $84. So we can see which ordered pair is going to maximize income for her. It's 156. So Ariel should make 18 regular cards and 14 custom cards in order to maximize her income. All right. If you need to go back and watch some of this again, rewind and give it a try. Go ahead and try to give number 2 a chance on your own. I'm going to make a video, a separate video, and you can come back and watch that.